look at today to continue our look at the law of sines is, first of all, I want to look at one related. It's not the law of sines, but it's a formula that's related to the law of sines and whatnot. And it's a formula for finding area. And then I also want to look at the third case that I mentioned yesterday. Yesterday we looked at angle, angle, side, and angle, side, angle. If we're given that information, we can use the law of sines. I want to look at this third case because it's what's known as the ambiguous case. Because in certain circumstances, you can use it and find the answer, and that'll be the only answer. There will be other cases where you'll know that, and then you'll realize that, hey, it's impossible to make a triangle out of those pieces. And then thirdly, you'll find a case where, given that information, there's actually two different possible answers. Okay? So, I just wanted to point that out there. Okay, so we'll get to that in a moment. What I want to first of all, though, do is see, how would you find an area in this triangle? We know that the area of a triangle is 1/2 base times height. But in this case, we have C, we have side B, and we have angle A. How would we find that area? Luis?
First, find the height, like divide the triangle in half.
Okay, find the height. So, if we did that,
And then sine 50 is h over 12.
sine of 50 is h over 12. Okay,
And then,
and now we know what h
Yeah,
is.
yeah.
Okay, h is 12 times the sine of 50.
And then we have
What in the world? Sine of 50, if it will let me read. Let's try that. No?
expand the page. Maybe.
That is goofy. For some reason it thinks my finger is the eraser. Let's try this. Up here. Okay. Alright, so sine of 50.
Now we need to calculate the height.
Now we can use our 1/2 base times height, right? So instead of area equals 1/2 base times height, we have the area equal to 1/2, the base is 10, times our height, 12 times the sine of 50. Okay? So good. I mean, that's not that hard of a process, but I want you to see before we actually simplify to find the answer, notice what we end up doing. Okay? We know two sides, and we know the angle between those two sides. Okay? We know two sides and the angle between them. Okay? And what ends up happening is we end up taking 1/2 times the two sides times the sine of the angle between them, right? So this right here, this formula, or this process, we could repeat for any triangle where we knew two of the sides, let's say 7 and 12, and we knew that this was 40 degrees. We could find the area using the same process. A equals 1/2 times 12 times 7 times the sine of 40. Okay? And what we've now done is we've now recognized that in a given circumstance, this is going to be the process that we'd have to use every time. So let's make that into a formula, okay? And I call this is not an official name for this, but I always call this the SAS, that side angle side area formula, because this reminds me what I have to know in order to use this formula. But the area of any triangle is half the product of the lengths of two sides times the sine of their included angle. Now, an included angle is just the angle between the two sides. Okay? So in this case, I would have our area equal 1/2 times A times B times the sine of angle C. Okay? Now, you can see up here there's different variations depending on which two sides and which angle you know, but they're all the same pattern. We have two sides with the angle between them. So I found that 1/2 AB sine of angle C is the easiest for me to remember. Okay? So given that, let's say that I know that I have sides that are, let's say 15, and this side here is 12, and let's say this angle right here is 35 degrees. Okay? So what would the area of this triangle be?
1/2 times 15 times 12 times sine 35.
Very good. Okay. Not too bad. So all I have to do here is I simplify. Okay. 6 times 15, it would be 90 times the sine of 35. All right, and what does that end up giving us? 51.62. And this is square units, okay? Square units. All right. So, not too hard a formula to work with. Just one thing that we want to make sure we remember, because one of the natural applications of what we're doing by solving these triangles is then being able to find areas for these triangles, okay? But we'd rather find areas without having to find extra parts, you know, breaking it into a right triangle and all of that stuff, okay? Now there's another area formula we'll talk about later called Heron's formula, and that's for if you know all three sides of the triangle. Okay, that one's not too bad either. Okay, so let's get to our third pattern for when we'll use the law of sines. Okay. There's a number of different cases, okay? And it all has to do with the comparison of a side and a height, okay? Now, let's look through this table of information and let's see what we can figure out, okay? First of all, we want to consider a triangle in which you're given A, B, and angle A. In other words, we know a side, another side, and then an angle that's not between those two sides. Okay? If we knew side, angle, side, we can't use the law of sines at all, and there won't be any ambiguous case in that case. All right? Well, we know two sides and an angle that's not between them. Okay? But notice here that one of those two sides will be across from the angle you know. Okay? Again, that was the key to being able to use the law of sines, is we had to have a pair that were across from each other, right? Right? Yeah. Okay. Now, let's look at the things that we know already. Okay? We've already dealt with right triangles, okay? And actually, let's look at ones where we're going to get one exact answer, okay? So in this case here, if our angle is acute, okay, it's possible we could have a right triangle. All right. Now you may not recognize it as such, but right off the bat, but you could have a right triangle here, and in that case, this side over here would equal the height of the triangle. Okay, that proves that it's a right triangle. Here, also, if A is acute and A is longer than B, you're going to get one solution. Okay? Over here, if A is obtuse and A is longer than B, okay, you're going to be able to get just one solution. Okay? So, a couple of things here. If our angle is acute, obviously in the case of a right triangle, A would be what compared to B?
Be smaller than B.
It'd be smaller. Why do we know that? Because B is the
Hypotenuse.
hypotenuse. All right. So this is kind of a unique case right here. Okay. But you'll notice in both of these cases here, A has to be at least B. Okay. It's possible we have an acute isosceles triangle. Okay. If it's obtuse, A definitely has to be the longest side because the obtuse angle would be the biggest angle, right? Okay? So let's look at these other three cases. The other three cases here are ones that would cause us to fail one of those properties that we looked at yesterday. Okay? So, you'll notice here, you know, how is it possible to have a situation where the triangle is impossible to make when we have an acute angle, okay? And this one, it's not real evident right away, but as you work it out, okay, you would end up realizing that there's a side across here, across from your angle, that is too short. No matter how long you make this side and no matter what the other angles are, this side here will never hit the other side of your triangle. Okay? And let's look at an example of this. Okay? Just get rid of that. Let's look at an example where this would take place. All right, let's say we have a triangle here, or we're trying to make, theoretically we have a triangle here, and we have these sides labeled. Let's say this is a 50-degree angle, and this is 2 units long. We'll go with inches, 2 inches long, and this right here is, 15 inches long. Okay? Now, naturally, we would want to try to find this angle right here next, right? And it doesn't matter what these are labeled, so I'll just label this angle A. Okay? How would I set up the law of sines to try to solve this?
Sine of 50 over 2.
Sine of 50 over 2
Sine of A over 15.
equals good. Sine of A over 15. Alright? So let's think about this. What's the sine of 50? Okay. I gotta solve this, so I'm gonna multiply by 15, right? So sine of A equals sine of 50 times 15 divided by 2. What do we get here?
5.745.
Okay.
I think.
Did anyone else get that?
Yes.
Yeah, 7.
Because that looks weird, right? What looks weird about that?
The sine can't be greater than.
What?
The sine can't be greater than 1.
Okay, that's the key here. The sine of an angle has to be between 0 and 1, or negative 1 and positive 1. Okay? So here we have sine equal to 5.7. That's not possible. Now, rule number one, don't just jump to conclusions here. What should you do first?
Check your work.
Double check your work, okay? If you're getting a whole lot of them turning out this way, you're probably doing something wrong. All right, because we actually want you to get some practice solving these. All right, but obviously sine of A cannot equal 5.7, so there are no possible triangles that you could make with a 15-inch side, a 2-inch side, and a 50-degree angle like that. Okay? Now, if this 50-degree angle were in one of the other two spots, maybe. But you can't with this arrangement here. Alright? Does that make sense? Alright, good. Now let's look at the other possibility here. The other case where it's impossible, alright, and that is if our angle is obtuse, we already said if you have the biggest angle,
You can cross from the biggest side.
it has to be across from the biggest side. So if A, we don't even need to make an example of this one, because look, if A is less than B, or even equal to B, because if it's an obtuse angle, we can't have another obtuse angle that would make sides congruent, right? If A is less than or equal to B, that's going to be impossible. You're not going to be able to reach the whole side like you would over here for an obtuse triangle. Okay? So that's another case here where we get something that's impossible to make a triangle out of. Alright, so just kind of reviewing here. This one, there's no real good way of just looking at the problem and being able to see it. Okay? When the angle's acute. This one here, though, before you do any work at all, if you look at the picture, label the sides, and you say, wait a sec, the angle across from, or the side across from the obtuse angle is not the biggest side, then you know that's impossible. You don't even have to do any work. Just put not possible, biggest side is not across from the obtuse angle, or something like that. You know, don't just put, you know, oh, no solution. You know, give some kind of a reason. Explain what's going on. Okay? Now, none of these, both of those give us no possibility. We looked at the three cases where we get one possibility. Where this is really ambiguous is where we have more than one possibility. Okay? This is particularly, you know, kind of challenging to see, because if we're not paying attention, everything looks great. Okay? So let me think here. Let's say that we're given a triangle where I need side angle. Let's see here. Again, this is one that's not going to be real obvious just by looking at the information. Let me see here. I think if we do like the sine of 40, and if we make this, let's say we make this one here
13.
7, and let's make this one 6. Okay? No. Hang on. Let's do this. Let's make this one be, we'll make this one be 13. Okay?
Thank you.
Alright, so the next natural thing here would be to try to find this angle over here. Okay, we'll call this angle B. So again, I'm going to use the law of sine. Sine of angle B over 13 equals the sine of 40 degrees over 7. Okay? Now you do this.
You get 1.1937. 1.1937.
Wait, when you multiply by 13?
Yep.
Well, that's impossible. So we need to, let's do this. Let's make this 11. Okay? So sine of 40 divided by 7, then times 11, sine of b equals...
1.01.
Really?
Still
Oh, come on.
0.0009.
What?
Alright, let's try 10. What do we get?
0.9182.
Alright. Whoops.
Actually, it's 0.9183 if we're running at technical.
Okay, so sine of b is 0.9183. Okay, now, when you hit inverse sine, what do you get? Angle b equals,
66.67.
no,
Yeah, that's what it
sine is almost 1. It should be somewhat close to 90.
says 66.67.
Off the top of my head, I'll guess 89.1.
66.60.
You got 66.67?
Yeah.
Okay. I must just be off a little. Alright, so 66.67. Now, question, is that the only thing that angle B could equal?
No. Equal
Oh,
to
but there's just
y.
another point. That's just the reference angle.
Okay, there's two possibilities here, right?
Yes.
If that's my reference angle, what would the other angle be?
113.33.
117?
No, 113.
Oh, 113.33. Okay? So it's possible that I have this acute angle. It's possible that I have this obtuse angle. Now, before you just jump to this conclusion, jump to saying, oh, well, there's two possible solutions, you need to consider if this is actually possible. Okay? Now, the acute one will be possible. The question is, will the obtuse one be possible? Let's try drawing this and make it look, you know, like a 113.33 degree angle. Okay? We could have, you know, 66.67 right there. Okay? The other way, though, angle B would be an obtuse angle, right? Let's say that's 113.33. This would be 7, this would be 10,
Yeah, that could work.
and this would be 40 degrees. Is there anything mathematically that would make that impossible? No, okay? Now, for example, if this side were smaller than 7, you know, we wouldn't have an obtuse angle. Now, this one won't work either. But you'll see something like that happen, where you're going to get a side across from an angle and it doesn't match up, all right? But in this case, both of these are viable options. And as a result, we have two different triangles that are both possibilities, okay? Now, just to show you what this would look like, okay, we could have, the 40 degree angle, and let me try to draw this kind of a little bit different here. I could either have, if B was on the top here, I could either have, you know, 66.67, or I could have this 113.33. Okay? Now, if you look at where these would be in relation to it, let's see, we'd have the 40-degree angle here, okay? And let's see, the 10 would be across from here, and the 7 would be across from the 40, okay? So we have, again, two different possibilities of what this triangle could look like. And obviously, that'll change what this third angle is, and also what the third side is.
Are there two possibilities? The triangle right there, like right there and there?
Yeah.
But what I don't understand is, so the 113.33 degrees, you just got that because it's the complementary angle?
Well, because sine is positive in the first and the second quadrant. Okay? This is what makes the law of sines this a little ambiguous in this case, is that sine is positive in both of these quadrants, and it's possible to have an obtuse angle in a triangle.
So not in like previous examples, we've only got one answer.
Well, let's well, in previous examples, we weren't given side-side angle.
So because we give us an angle, that allows us to then give different answers?
Yes, in some cases. We can see here, even given side-side angle, there are cases where, yeah, there's only one possibility. Okay, we saw those 3 cases there. But there's also the possibility that there's no solution, and there's the possibility that there are 2 viable solutions. Okay? Mm-hmm.
So like in the other ones, because there's always like 2 answers for sine, right? So what if like in the other ones like before where it's like angle on the side, what if like the complementary angle was the one that worked, like if it was an obtuse triangle and you're looking for that obtuse angle? Like would that ever be the case?
Well, let's, do we have that up still? Where's here? Okay. Let's consider one like these. Okay. Here's one from your homework
So like
where we were given angle, side. Here, if you know 2 angles, there's only one thing that C can be. I mean, I have to subtract these 2 from 180, and this is 95 degrees. There's no other possibility here. Okay? Here, 35 and 55 add up to 90. This has to be a 90-degree angle. Okay? This has to be a 30-degree angle. Okay? And it came down to, in these, we weren't using the sine to find an angle. We were only finding sides. Alright? So here's the thing. When you're finding the side of a triangle using the law of sines, you don't need to worry about the ambiguous case at all. Okay? But if you're finding an angle, in the case here where we know 2 sides and an angle, the first thing you're going to have to find is that a second angle. So you do have that potential for the ambiguous case. Okay? Now let me draw another case here, and I'm going to start with the drawing so you can see the 2 possibilities. Okay? Let's say that we have this side, and I don't know how long this other side is. Okay? But here we have an angle, and let's say this angle is 52 degrees. And let's say that this side here is 13, okay? This other side could be the same length if it went here or if it went there, okay? So I could have, this triangle right here, which would make it an obtuse triangle, or I could have, let me do a different or I could have this triangle right here. That would be an acute triangle. Okay? It all comes down to this angle versus this angle. And they will have the same reference angle, and they both will be valid possibilities. Okay, so let's say that this side here, let's say this side here was 9, okay? I could have 9 coming in like this, or I could have 9 going out like that. And when I'm trying to find, I'll put B for both of these, even though, you know, only one of them would be, maybe I'll do B1 and B2, okay? Because those are our two possibilities. Alright, the sine of whatever angle B is over 13 would equal the sine of 52 over 9. Okay? So then sine of B would equal what in this case?
13 times the sine of 52 divided by 9.
Yeah. Okay, so what's 13 times the sine of 52 divided by 9?
1.138.
Really?
1.12. Or 1.14, I mean.
Hang on, we need to...
1.13823775529.
Hang on, what's 13 times the sine of 52? Can someone tell me that?
10.244.
10.244. So let's make this 11. Okay? Instead of 9, we're going to make this 11.
9313.
Alright, so there's 11. So 13 times the sine of 52 over 11. Okay? That's why these ones are hard to make up.
0.9313.
Okay? So 0.9313. So the inverse sine, when you hit inverse sine, what do you get?
68.64.
Okay? 0.64. So that one would be this possibility here. That would be the B2. Right? 68.64. What would this possibility be?
111.36.
Okay. It would be the angle in the second quadrant that has the same reference angle.
Makes sense.
Okay? Both of them are possible. But obviously, this side here would have to be shorter to have the 111.36 degree angle. This side on the bottom would have to be longer in order to make this an acute triangle. Since we weren't given that side, it can be anything. Alright, so it's just now that we know this information, we could then figure out the possibilities, okay? So we have... Here's our 111.36. Here's 11. Here's 13. Here's 52. We could finish solving for this side and this angle. Or, here it is when we have a 68.64 degree angle. We have 11 and we have 13 and 52. And we could solve for that side and that angle, but they're going to be different. So we could split it up into two separate cases. Alright? Does that make sense? Alright. So that's our ambiguous case. Obviously, I'm not going to assign homework for this. We're going to look a little bit more at this and practice with the law of sines on Friday. But that's everything that we need to know about the law of sines. We just need to be careful when we're using the law of sines to find an angle to see if there is a possible second option. Okay?